Continuing with ratios, we're looking at ratio tables today. What is a ratio table? Ratio tables are tables used to understand the equivalence of two related numbers. On the right, I have a table of sugar to flour, which we've discussed several times. The ratio here of sugar to flour is 2 to 3. Remember, order matters, so I have to have sugar first and then flour second. Make sure to always label your tables. The ratio of weight on Earth to weight on the moon is approximately 60 pounds to 10 pounds. So I'm going to label my table, weight on Earth and then weight on the moon, and then I put the numbers where they belong. So 60 pounds on Earth, 10 pounds on the moon. And then I can expand my table. So the first time I went, I divided it by 2, and so I have 30 pounds on Earth, which means I have to divide the moon by 2 as well to get 5 pounds on the moon. So 30 pounds on the Earth equals 5 pounds on the moon. We can continue that out by taking the 30 and multiplying by 3. So we see 90 pounds on Earth is 15 pounds on the moon. The school has planned a pizza party for the 6th grade tomorrow. The pizza parlor said 2 pizzas would serve 9 students. So on my table here, I start by labeling pizzas and students, and I have 2 pizzas to 9 students. Then I went up to 10 pizzas. So when I did that, I multiplied by 5, and that means I need to multiply by 5 for students so I can see how many students it serves. Let's look at A. Tracy is in charge of ordering the pizzas for 450 students. How many pizzas does Tracy need to order? So I have 45, and how do I get from 45 to 450, which is the next label on our table for students? I multiply by 10. So that means I need to multiply by 10 on the top as well, which means I need 100 pizzas. If Tracy orders 12 pizzas, how many students will it serve? So we might need to go back to our original label in our table because I believe it's easier to get from 2 to 12 by multiplication. So what do I multiply 2 by to get 12? That's times 6. So I'm going to do the same thing on the bottom. And that means it will feed 54 students. The band decided to order pizzas for their party. If there are 90 students in the band, how many pizzas do they need to order? So if I go back to the original amount, I can go from 9 to 90 by multiplying by 10. So I will take the number that corresponds to the 9, which is the 2 pizzas, and multiply that by 10 as well, and get 20 pizzas. Assume each of the following represents a table of equivalent ratios. Fill in the missing values. So I start with 3 to 5, and from 5 to 10, I multiply by 2, so I need to take 3 and multiply that by 2 as well to end up with 6. Now the next value I have is on the left-hand side, and I go from 3 to 9. So 3 times 3 is 9, so I need to go 5 times 3, which is 15. Here, I can see 9 times 2 is 18. So I can do 15 times 2, which is 30. For the 50, we can go back to the original 5 and see that's times 10. So I can multiply the 3 times 10 as well. And then the 5 times what equals 100? 5 times 20 equals 100. So 3 times 20 equals 60. It takes 3 parts blue paint to 2 parts yellow paint to create the green color. The art teacher needs to mix different quantities of green paint for several school projects. So I have my table labeled, green paint's 5, yellow 2, blue 3. How much yellow and blue paint is needed to make 15 pints of green paint? So I can start with my original ratio and say, well, what does it take? What do I multiply by to get from 5 to 15? And that's times 3. So I'm going to multiply all my ratios times 3. And that gives me 6 pints of yellow and 9 pints of blue. How many pints of green paint can be made with 12 pints of blue paint? So I can go back to my original 5 to 2 to 3 ratio and say, well, how do I get from 3 to 12? I multiply by 4. So that means I can multiply all my values by 4 to fill in my table. So I can see at the top, 20 pints of green paint can be made with blue paint. 12 pints of blue paint. Okay, you try it. You're going to use the information from example 3 to answer the following questions.